What's up, everyone? Today we're going to talk about Spearman's rank correlation coefficient. So what I want you to do first is with these 6 film genres, I want you to rank them in order of how much you like them. With a 1 being you like it the most, a 6 being you like it the least. You have to rank them all, and there are no ties allowed. All right, so here are my rankings just for your knowledge, but also because we're going to need it on the next slide. All right, so now what you're going to do is you're going to compare your choices with my choices, or your ranks with my ranks. So what I want you to do is you are going to write your rankings in the U column. I have mine in my own column. The lowercase d column is going to be the difference between our ranks, and it doesn't matter if it's positive or negative, because in that last column, we're going to take that difference and we're going to square it. So this last column should have all positive values, and you're going to add them up. Once you have that total, you're going to do 3 different calculations successively with it. So first, you're going to multiply it by 6. Then you're going to take that product and divide it by 210. And finally, you're going to subtract that quotient from 1. And what you should get is a number between -1 and +1. So we had just talked last class about Pearson's product moment correlation coefficient, which is also between -1 and +1. So that's leading us into what we're talking about today, which is Spearman's rank correlation coefficient. It is the product moment correlation coefficient of the ranks of a data set. And IB uses the notation R sub S, and the formula for it is here. That formula is not in the formula booklet, but that's because you won't need to do it by hand on an exam. You might need it depending on what your internal assessment in year 2 looks like. You might need it for that, but you'll never have to memorize this or do it by hand on an exam. All right, so what Spearman's rank correlation coefficient is, its purpose is it shows the extent to which one variable increases or decreases as the other variable increases. A ranking value of 1 means that the data set is strictly increasing, and a value of -1 means it's strictly decreasing. Data that is only increasing or decreasing is known as monotonic. A value close to 0 just suggests that the data isn't consistently increasing or decreasing. All right, so how to find it in your calculator, just because I said you won't have to do it by hand. What you do is you first have to rank the x values and the y values from smallest to greatest. So you'll always start at 1, and you'll go through however many data points you have or data values that you have. If more than one piece of data has the same value, the rank given to each of those is the average of the ranks of where you are. So for example, if you're trying to give a ranking of a 4 and a 5, both data values would get a 4.5 or a 4.5, because that's in the middle of the 2 rankings that you're looking at. And your next data value would get a ranking of a 6. And we'll go through examples using that. So hopefully using an actual example, it'll make more sense. Once you have the ranked data, all you do is you put them into your list, into your calculator, just like we were doing with Pearson's product moment correlation coefficient, and you find the R value in the calculator. So it's really just that first step that's different. Everything else is the same as finding Pearson's product moment correlation coefficient. So let's do a couple examples. So here we are looking at, in letter A, we're looking at the time spent training, and then the time spent the time to run a 2K or a 2-kilometer race. So what we'll do in the time spent training is I'm just going to rank them from 1 through 1, 2, 3, 4, 5, 6, because I have 6 values. So my lowest is 17, so that's going to get a 1. If you notice, my next lowest is a 23, but I have 2 of them. So they would get a 2 or a 3, right? And in order to indicate that they're both the same and not put one over the other, that's why we're going to give both of them an average of 2 and 3, which is 2.5. My next highest is 29. So technically I've already used rankings 1, 2, and 3. So my next ranking would be 4. And then my 34 is next with a 5. And finally my 45 is the last one, or the highest one. I'm going to do the same thing with my times. So my lowest is 8, so that'll get a 1. Next is 10, so that'll get a 2. I have two 11s, so I would be at ranking 3 and 4. So the average of 3 and 4 is 3.5. Next, I have 12, which would get, I've already used 1 through 4, so this is going to get a 5 and a 6 for 14. So into my calculator, I'm doing my x values into L1, my y values into L2, and I'm finding my r value. Just like we were doing before, use the linreg and look for that r value at the very bottom. And when I do that, I get negative 0.956. And even though the directions only ask us to state or to find Spearman's rank correlation coefficient, we're going to also interpret these just so that we understand what that value means or how to interpret it. So because this is negative, what that tells me is that as x increases, y decreases. But in the concept of the actual problem, what that means is that the more time I spent training, the faster my 2K time was, or the less time I was spending to actually run that 2K. All right, and for letter B, same kind of idea. We got the number of pets. Luckily, it's not only in increasing order, but it starts at 1 and it goes through 5, so we're good there. For the time spent each week caring for them, it's in order, but we still have to rank them out. So this is already going to be set up for my L1, but my L2, I can at least go mostly in order, 1, 2, but I can't just say 3, 4 because these are both 8s. So they're both going to get a 3.5. And then I have my last ranking of 5. And then same deal, I'll throw that into my calculator, find my R value. Because both increase, we should automatically know that it's going to be positive. But still finding my R value, I get it to be 0.975, which again, because it's increasing, that tells me that the more pets I have, the more time I'll spend caring for them each week. Now, obviously, when you're interpreting them, it doesn't have to have these exact words, but as long as they mean the same thing, that's what matters. Finally, some advantages of Spearman's rank correlation coefficient over Pearson's product moment correlation coefficient. First of all, that it can be used on data that's not linear. Pearson's is restricted to only linear data. So Spearman's can be nonlinear. It can be used on data that has already been ranked, even if the original data is unknown or can't be quantified. And it's not greatly affected by outliers. When we have outliers using that Pearson's product moment correlation coefficient, it can skew the data. It brings everything onto a similar scale, so it's not going to be affected by outliers at all. And so one more practice problem, but I'd like you to pause the video, try this one on your own, and then check back here for the answers. So our data that we have here, a student was asked to rank 9 different makes of burger in terms of which one she liked best to which one she liked the least. She put a 1 for the ones that she liked the best and a 9 for the one that she liked the least, and obviously ranked them from there. These rankings and the cost of the burgers are given in our table. Part A, explain why you can't use Pearson's in this example. So because she ranked them from the beginning, it's already ranked data, so we have to use Spearman. Part B, finding Spearman's, or we're asked to find Spearman's rank correlation coefficient for this data and comment on our answers. So obviously the taste itself is already ranked, so I'm just going to have to run through ranking the cost, and then I'll plug it into my calculator and find R. All right, so I have my data ranked. When I throw that into my calculator and get my R value, I get negative 0.800 to 3 sig figs. So what that tells me, you need to remember how she ranked these. She put a 1 for the one she liked the best and a 9 for the one that she liked the least. As the ranked number increases, the cost of the burger decreases. So what that means is as the burger taste went down, just because of how she ranked them, the cost also went down. So you can say that either way, but you just have to make sure anytime you go to interpret it or comment on your answer or how were the values actually ranked. So even though this sounds a little bit backwards just because it's a negative R value, again, because of how she ranked them, that's something along the lines of what you should have.